Okay, so what we're going to have is 3 different meters. All of them again are the same meter, and they're sitting up on the block so that I can show you the test blocks that are in the back as well as the meters at the same time. I've added a little bit of light so we can make sure that we can see pretty well, and hopefully it'll show up well on the video. This meter right here is always going to be volts. This meter is always going to be amps. And this meter is either going to be hertz or it will be the other voltage of the other side of the coil, and I will illustrate that, or I will say which one this one is when we do each test. This one is always amps, this one is always volts. And I've tried to set it so that you can see where the dials are sitting and also our wire connections as well, at the same time as our connections for our test blocks. So hopefully all this will show up in video. If you have any questions, please email me. Okay, so our first test is going to be our main coil that's going to be coming off of here. So what I'm going to do is I'm going to simply insert these into our test block. And I'm going to tighten down our test block just enough to hold it in place. And all we're testing here is the volts. Okay, so this one we're going to set to volts, and you'll see the meter come up and it'll zero out. And I'm going to set it for AC, so you can see that the meter is set on AC and it's going to zero out. Our amps meter is not going to be used right now because we're only checking voltage. So on this voltage test, we are going to use our other meter, and we are going to set this at voltage as well. Now on this particular meter, if you'll look, you'll notice, I'm going to shield the light just a little bit so you can see those LEDs that are backlighting our meter. So you can see exactly where that you're supposed to plug in for each reading. And this will change. If we set this on milliamps, you'll see that the lights change. So you can always verify, because of where these are on this particular meter, where we're setting. So we have our first set of wires here coming off of this meter that are reading AC volts going to our large wire. And you're going to see this one, I'm going to select that to AC. And you will see this side that will go to our AC on our smaller wire size. And again, I'm doing the same technique here, loosening our screw lugs, putting our wires in there, and then locking it down. Now, as you can see, both meters are at zeros. They're both on ACs. And we're going to go ahead and start it up. So I'm just going to turn on the drill press, and you'll see that in just a second. I'm going to move the camera up slightly so that you can see all of that in working. So you know where our contacts and our wires are going. I'm just going to reset this wire, and then I'll go ahead and turn this on. And immediately you'll start to see our voltage climb. And you'll notice that the two wires are going to be slightly different in voltage. You'll watch the voltage climb while the coil gets to running temperature. And we're going to top out on these at about 18 volts, or a little bit under. So on each side of our coil, we're getting about 17 volts, 17.5 volts. Slowly watch the meters climb up here, and you'll see that in detail. Now you'll notice our two meters are slightly changing, and the reason why is because of our wire size difference. difference here. Now what I'm going to do is I'm going to change our voltage here, and I'm going to put this on our DC side. So what I'm going to do is turn our meter off for a second, and I'm going to change that to our DC side. Switch on our meter. It's already set for DC, and you'll notice that we're going to get slightly under what we were getting with AC. And the reason for that is the bridge rectifier here does absorb some power when it changes the oscillating signal into a single signal. So when that happens, it does consume a little bit of power. These are way overrated for the coil that we're driving here. These are rated up to 4 amps and 200 volts. So we're definitely under where they're at. But I wanted to show you kind of the difference on when we rectify it versus non-rectifying. Okay, so what I'm going to do here now is I'm going to show you directly the power regulation between these two. So I'm going to take our AC out of our small wire, and I'm just going to put it back to our large wire. So you'll see our DC voltage on this meter and our AC voltage on this meter. And I'll do that now. I'm going to turn the meter off. Do is turn the meter on and get it set for AC voltage. And now what I want to show you here is the voltage difference between DC and AC off the same side of that coil. So you can see that we're generating 18 volts here of AC, and DC voltage is 16. So you can see that we do lose some power through a rectifier. Okay, our speed on our rotor was 3000 RPMs for that test. We tested our large wire AC output. We tested our small wire AC output, and we tested our DC large wire output. The small wire DC output is going to be in the same relation as what we had on our AC output as far as the voltage change. So you're going to see about 1.5 volts difference between the AC and the DC if we rectified it. So that's going to be the same for that section. What I'm going to do next is I'm going to pair coil this, and that will give us a brand new reading for our power. And I'm going to show that in detail here and how I do all of that, show the wire hookup so that we can show the testing on that. Our coil in here is a bifailure coil, and the two wires on this is a 26 and a 22 AWG. There is 140 feet of wire on this coil to produce the power ratings that you've seen here. Thank you.